Okay, let's go atmosphere. First question, quite straightforward. Most people did really well on this one. Straight up comparison. So all you need to say that there was more oxides of nitrogen for biodiesel, and then there would be less particulate matter in carbon dioxide, or you could get away with saying it the other way around. People might have lost marks because you might have just said there was more nitrogen or less nitrogen. You've not said it's nitrogen oxides. That was one that you seemed to pick up on, even if you were quite good at saying particulate matter in full. And the other thing that you might have done is just repeated the information that's in the table. If you literally just say there's 108 in biodiesel and 100 in petrol, you haven't actually made the comparison in itself. You have to use a comparative, like more, less, larger, bigger, smaller. So you could have been very close to 3 marks, but actually get nothing in doing that. The second part, very well done overall. We're looking for a bar between 84 and 86. Be careful on the scale. If people got this wrong, they were usually going for halfway between 80 and 90 and putting a line. Halfway between 80 and 100, and that would be 90. We're actually meant to go halfway between 80 and 90, so that'd only be a quarter of the way up this box, roughly speaking. The reason that you're going for 85 is that there's 100%, and then you find out that this one, and this one added together is about 15%, depending how you're reading the scale. So 15% off the 100 leaves 85 to draw in the box here. Which gas is needed for burning to take place? Very well answered overall, oxygen. 1.4, very well answered again. Carbon dioxide is for global warming, sulfur dioxide is for acid rain. The only incorrect answers really there for that one was the only incorrect answer was drawing more than one. I'm not quite sure why it says 3 marks available. There's only 2 available for that one. Maybe they've someone's edited the test and taken away one of the answers there. Question 2. So state the name of the process for which plants produce oxygen. Photosynthesis should be your go-to obvious answer for that one for me, please. Loads of people didn't get the photosynthesis equation right, despite us doing it in class, and it is one of the most important things that you need to know, and at your level for doing the triple award, not just word equation, you should be looking at knowing the symbol equation for it and how to balance it. So we're looking at carbon dioxide and water going into it, and on the right hand side we need to have glucose with oxygen already given. I get a mark for doing the left hand side and a mark for doing the right hand side. Most common incorrect things, leaving blanks or writing the word light in it. Light's not a substance, it doesn't appear in the actual equation itself, so whereas it does need to have light happening, the process is also endothermic, but we've not included that. Just like when you've got something burning, you don't say plus heat in an equation, so just be careful there. For number 3, graph skills once again struck to let us down. You need a single curve that of best fit drawn through as many of the points as possible, and it says specifically here in the mark scheme, don't accept lumpy curves. That's where it's going to try and basically dot to dot and include a lump up as well. When it says don't allow multiple strokes, if you've got any bit where you've sketched and moved your pencil back and forth and you can see little tram lines forming, that's not appropriate. Also, if you've got a big fat pencil and it's very difficult to mark out where you actually have a specific point, that's also losing you the mark. For 3.2, concentration of the carbon dioxide in 1960, it was a case of just finding 1960, reading up to your line of best fit and reading across. It should get you around about 318 as it says here in the mark scheme, but depending where you drew your line of best fit, then we could carry that through. We could give you the mark according to where your line was. It says give 2 conclusions you can make from the graph at 3.3. There's 2 points we're looking for. You link both axes, so you say the concentration of carbon dioxide from this axis has increased as the time has passed, or the number of years have increased on this axis. The second point is and it's only linking to the information in this graph. It's not about saying about trees being burnt or something like that. It's not a linear relationship. It's exponential, or it's getting faster and faster. So over time, it's not just that more carbon dioxide is being produced, it's more and more. It's increasing the rate every year, so it's getting more and more each year. For 3.4, loads of people got this wrong, and it's dead similar to when you just say factories. There's not been for hundreds of years factories that produce carbon dioxide themselves, because you don't usually get, well, it can happen, but you don't usually get them burning fuels in the factory. Well, people use electricity a lot these days. And Industrial Revolution in the 1900s, it was already done. You're in the wrong century. And it's asking for the process. So it's asking for a chemical reaction. So what you're all trying to say there is about the combustion of fossil fuels. So you do need to say something about burning or combustion or something like that. If you say an Industrial Revolution, it's not science GCSE territory, and it's not even correct for your history. So I know that you know what you're talking about there, and it's being careful with your wording to make sure it reflects your knowledge. For 3.5, some good use of percentages here, and some people struggling a little bit on this one. Some of you did really well where you looked at 1955 and you went up and found the graph 1955 up and across, and you read off and you had about 313 or thereabouts. And then you got 2005, so you went up, look, 2005, there it is, go up, read up, it's nicely 380. And then you gave up. So it says the percentage change. So it's changed from one of those numbers to the other. So the change is the difference between the two. So there's the first bit that we're looking at. It's got a change of 67 or 66, depending on where we gave the mark for that one. Second bit is working out for the percentage change. So it's changed 67 out of the original 313. So 67 divided by 313 times by 100. It's like a price change in a shop. If it's changed by £67 and it was £313 originally, the price has increased by 21%. Quickly moving on, number 4. So, question about the Earth's atmosphere. Scientists have been using data from the Kepler Space Telescope to look for planets, and look at the key information here. We're looking at planets that might be similar to Earth, and it says we're looking for early Earth, so it's not about current Earth. So a lot of people ticked nitrogen because you just thought, yeah, Earth's got mainly nitrogen. Good knowledge, but it's not what the question's asking. Early Earth's atmosphere is when we go in our time machine, travel back in time, step out, what's happening there? Oh, we can't breathe because it's mainly carbon dioxide. Why is it mainly carbon dioxide? 4.2. Volcanoes. If you don't think volcanoes is a process, then volcanoes erupting would be slightly more specific there. For 4.3, water vapour, what's happened to that one? I think we've hammered this one, it was well answered. It's the water vapour cooled. As the planet cooled down, that allowed it to condense and form the oceans. For 4.4, give one reason why scientists can find it hard to agree on one theory. The main thing we're looking for here is there's not very much evidence or proof, or even no evidence or proof, or it's hard because it's been destroyed. And because it was such a long time ago, it does say here in the mark scheme, ignore references to no one being there, because, yeah, humans weren't around at that point, but we can still look at things like rocks and things and look at the past. So again, it's looking at it in terms of GCSE science, trying to make it nice and specific, and rather than just saying there's no one there, and saying it's about the evidence, the proof. Because we're not so much about primary sources in science, about first-hand observations of people. For 4.5, if you're working it out from this pie chart, then you get 20% and 80% by seeing that there are 4 of these little wedges out of the 20 in total. You might just remember as well that I told you that to remember the facts, what it is. So it's 21% and 78%, so that's fine. And you can see they do allow a small range in values. Just working out from the pie chart though, 20% and 80%. This is oxygen, the smaller chunk, and the nitrogen is the larger chunk. For number 5, good news. This is something that we'll look at in more detail later on, where we're looking at combustion. So the balance in the equation, in fact the whole of this question, you'll get more chance on later on. For those that did do it though, here's how we're looking at it. There's 7 carbons in this originally on the left hand side, which will give me 7 CO2 as shown in the formula here. There are 16 hydrogens, so how many lots of 2 hydrogens will I need to make 16? I'd need 8 lots of 2, as you can see in the formula here. So if I have 8 waters, that gives me 8 oxygens. And then if I've got 7 lots of 2 oxygens in the carbon dioxide, that's another 14. Add them together, that gives me 22 overall. So how many O2s will I need to make 22? I'll need 11 of them. So that's where we get our numbers for balancing it. We're going to do more on balancing, so it is a skill that'll keep coming up again and again and again, so keep bashing your head at it and we'll get better. For part 2, just naming the products. People here commonly said carbon dioxide. It's not, it's a carbon and 1 oxygen, so it's carbon monoxide and water. You have to have both of those to get the mark, which hopefully in future should be relatively straightforward and not scary. And this is going back to my lesson where we're talking about chimney sweeps and different pollution that might get into the air. Why are these two different? Why are we getting carbon monoxide forming instead of carbon dioxide? It's because there is a lack of oxygen, or because it is incomplete combustion. So there's a range of things that it's saying here, but you need to link it to the fact that there's less oxygen available. For question 6, Earth is approximately 4,500 million or 4.5 billion years old. Huge amount of information here which you're going to need to come back to and look at when you're looking at the 6 marker next. So for 6.1 it says between which years with the rate of change of carbon dioxide concentration greatest, which was it greatest, sorry. The mark scheme says between 0 and 1,000 here. Most people went for 0 and 500, and to be honest, I would agree with you on that one, for the reason being that is where it's steepest, and it does start to curve off between these two bits. So I allowed that, and I think that you'd get an examiner allowing that too, because I agree with you on that one. For the next question, where we're looking at describing and explaining the changes in both oxygen and carbon dioxide levels, there's a lot of low scoring and not a lot of high scoring. So, stating the obvious, look back at the graph. There's lots of carbon dioxide at the start. It tails down very rapidly, and there's very little now. As for oxygen, it starts off very small, and it increases. So, we're given information in the question, use it. We're then about explaining it as well. So the most popular place where people have a chance to do it, they've talked about plants, photosynthesis, taking in carbon dioxide and giving out oxygen. So if you're giving me a basic idea like that and using a few keywords, that's where you're getting into 2 marks. Some people went on to talk about water forming oceans. It doesn't ask for that in the question. The next thing that you might then start to talk about is something like where else the carbon dioxide could have gone, for example, dissolving in oceans, reacted to form carbonate rocks. So if you wanted to get into the 5-6 territory, you'd need to be using a range of words. I'd be looking to see in your answer things like photosynthesis, carbonates, dissolved, carbon dioxide being taken into plants and given, and oxygen being given out, as well as a comparison on the levels. Maybe giving numbers off the graph, or at least saying it started off high and decreased very low, and giving a sort of a time frame, so quoting specific numbers. So that's what the 6 is going to look like. For 6.3, many scientists believe that carbon dioxide is warming the atmosphere. There's 3 steps that we need to include here. First step, the energy that we're talking about is coming from the sun. So you can be talking about infrared radiation, or radiation from the sun, or energy from the sun, or light from the sun. First mark. Second mark, it is going to be re-radiated or emitted from the Earth's surface. Second mark. So those are the 2 that quite a lot of people missed. The most common mark that people did get, if they only got, say, 1 out of 3, was by saying that carbon dioxide forms a layer that traps that radiation which is trying to escape. Please stop talking about ozone layers. Ozone layers, they're not anything in my lessons that you're going to be talking about, and it's not got anything to do with the greenhouse effect. It's not going to be something that you're tested on. So if you're talking about ozone layers, it's the wrong area to be looking at. Carbon footprint. Loads of people having a really good go at this one, and if you stuck the word dioxide in your answer, then it would probably be a mark. It is the amount of carbon dioxide generated by your activities. or an equivalent in carbon dioxide. So if you're producing methane, then they can calculate an equivalent warming effect that carbon dioxide would have of the same amount. 6.5, describe 2 changes the company could make to reduce its carbon footprint. So stay clear of the obvious but not specific enough things like just reduce the amount of fossil fuels. You're running a risk there by trying to say something like that. Try and be more specific. So rather than reduce fossil fuels, if you could do that, you would do that. Think about alternatives instead. So suggest specific alternatives like installing solar panels, or just say renewable fuels. Energy conservation was mentioned by some people as well, whether it's like insulating or turning off specific appliances maybe. You could get away with that. Carbon capture and storage or planting trees. Financial penalties for large polluters might also encourage that. Carbon neutrality as in biofuels, growing fuels that you can then burn after. Again, a concept we can come across in more detail later on. And last of all, 6.6. We're looking here at why countries might find it difficult to cut emissions, and that's the key bit, why they might find it difficult. So you have to explain the problem that they come across, not as a solution like you did in 6.5. So it might be that the solar panels you mentioned in 6.5 would be expensive, and that would put people off doing it. Or building hydroelectric dams would be expensive. So there could be the cost element in it. Changing over cars from petrol to electric cars would obviously cost a lot to the consumer, so people might not want that. It might be that your country is not suitable for it, or there's not enough renewable energy resources at the moment to provide for the demand that you would then have. Or even then, if you did start banning cars, if you haven't got an alternative transport system, if you don't have a good rail network, then or something similar to that, then again you're going to come across the same problem. People just can't get there without a car. And last of all, the lack of political resolve. That means, imagine you turn around and you say, I'm going to ban cars. What are the chances that you're going to get elected? And if you're already elected, how many people are going to continue to vote for you if you've taken away their pride and joy, or their way of taking the kids to and from the football matches and things like that? It's not going to go down well, so change has to be gradual and with the approval of people. Okay? Fantastic.